Hello, Maurieo! Maurieo Live number 3, Land Surveying 1 Q&A. Hello, and welcome. Welcome to my third live stream on YouTube. So far I've got 2 watches but no chat or no questions. The program's just started. It's 8 o'clock. And we're hoping to get underway. So yeah, please organise some questions and what have you, so that we can get a bit of feedback. Now I'm going to eventually, if I don't get anything, I'll oh hey Giselle, just wanted to find out how to work out the orientation correction. Okay, the orientation correction. I think I might just have a little video here on the orientation correction here that I'll put up on the screen for that. So I'll just put that on now. So here's a bit of an example that I had out of my simple concepts. But the orientation correction, if you can see here, please comment, Giselle, if there's something that you there. But here's your at we've got some left and right face. So 163, 15, 20 is our back bearing. That's our known bearing from ITMM to iron spike 4, as it turns out in this particular example. So what we're generally trying to do is we're trying to set the instrument up so that it reads 163, 15, 20 to iron spike 4. But that's generally impossible to get it exactly right. We can only get it close because we do have slight differences between left and right face, and it is very difficult to make exactly, get it exactly. So here we go. We've set it up as 160 or 1520 is what we've aimed for. But when we read on left face, we get 163, 15, 16. And then we flick it over onto right face, we get 343, 15, 38. Now we take the mean of those two, the mean, just the minutes and the seconds. It's expected that the left face and the right face, the degrees will be 180 degrees different, either plus 180 in this case, or minus 180 if you look at the next door one for ITXX. And so we take the mean, and there we would see our mean is 163, 15, 27. Now we were trying to get 163, 15, 20. So we subtract 7 seconds from that to make it equal 163, 15, 20. And that 7 seconds is our orientation correction, and it's always based on our back sight to our back bearing, or to our back sight to our known mark. Now therefore, when we measure to the other marks from that setup, ITXX, BM27, peg A, peg B, we do left and right face, we mean those, and then we apply the same orientation correction to make everything in terms of the things, because the angle between them stays the same. And so if we've moved everything around, or back 7 seconds, we must do that to all of the other ones in the setup. Otherwise, so that maintains the angle between iron spike 4, ITMM, ITXX remains the same, because we apply the same orientation correction to it. And so that is how you work out the orientation correction. I'm hoping that has done the trick for you, Giselle, and that might explain the orientation correction, unless you have any further questions on that one. You could let me know. Yeah, Well, that was a good first question. Thank you for that. If there's anyone else out there, well, the other person out there might have a question at this point. So yeah, just trying to get a handle on this lag. It seems to be. I'll just change the screen and see how long it takes. So I'm changing the screen now at let me see, 11:45, and I'll see how long it takes for it to flick over onto my where I can see it on my YouTube. So it's 10 seconds so far, coming up 15 seconds, and there's 20 seconds, and 25, almost coming up 30 seconds now, and it's still there. It goes. It's about a 30-second difference between when I change the screen and go back. So I'll transition back to me with the live chat, and yeah, it'll be about 30 seconds before it actually appears on YouTube. So we've got about a 30-second delay at the moment, it looks like, which is quite interesting. So I'm hoping that that's answered your question, Giselle, unless you've, I'm sure you'll ask more questions if it's not quite clear. All right, now I can just go back to some of my material that I had prepared here for this evening in the event that I didn't get any questions. So I'm going to, unless I get another question, I'm just going to talk a little bit. Oh, one more question. How do you work out the bearing misclose? Is that for the whole circle bearing question? Have you got a particular test in mind that you were perhaps looking at? I can have a look at I can get the actual question up here possibly, and see if so I know exactly what you're talking about. Okay, I'm just logging into the Moodle, Wintech Moodle. I don't know, I might not have enough bandwidth, but yeah, I'll see how we go. No, I don't seem to be able to log in. Test 2 traversing June 2014. Just seeing it. Oh, I've got in there. Yeah, hang on. So that's the tests. Let me see. The tests are in. Now, where are they? Total station. Oh, under assessment, aren't they? Yep, I've got Moodle open. I'm just finding the test at the moment. So traversing assignment 2. Oh, there's the test. Traversing tests. As a, I'll just get back to the chat. Question 1 on the table at the bottom. Yeah, test 2 Travis 6th of June 2014. Okay, yep. 2014 traversing tests model answers. Okay, getting there. Just see how I go. Okay, is this the one? I'll just put this here, and I'll transition that over onto the big screen. Is this the one you mean here? So just here, is it? Is this the question? 1A, whole circle bearings, or you say question 2? No, I don't. I think it must be this one here, is it? on page 2. I'll just have to look back at the where you're saying question 1 on the table at the bottom. It says bearing misclose. Is this the one you mean? I've got it up there. It's just coming up now. So it's at the bottom of that. Yeah, okay. So how do you get the bearing misclose? Okay, well, what you can see here is that you start at old iron tube 2022, you backside onto 21, and then you start going around and calculating all the bearings, and you come round. So when you get to the very last one, and this is in the unadjusted bearing column, you get 287 2010 is the bearing from old iron tube 47 to old iron tube 48. However, the final rounded bearing, which you get from the plan here, is 287 2100. 287 2100. So you can see that you would have to add 50 seconds to this unadjusted one here. 287 2010 plus 50 will give you what it is. So that 50 seconds is the bearing misclose. So that's the bearing misclose for there coming around here. So you started with this bearing and you brought it all the way with you, backside, foresight, backside, foresight, and you're using this backside you observed onto there, and you had 50 seconds. So you've got to distribute that 50 seconds amongst the 6 setups, or essentially 6 angles really. 1, 2, 3, 4, 5, 6. So if you divide 50 by 6, you get 6 eighths of 48 and 2 remainder. So you would do 4 lots of 8, which would give you 32, and 2 lots of 9, which would give you 18. 32 plus 18 would equal 50. So therefore you've got, I'm going to put 0 in there because that's true. So then I've gone 8 seconds, 8 seconds, so 8, and 8 is 16, and 9 is 25, and 8 is 33, and 8 is 41, and 9 is 50. So that's how I've put the adjustments in there. And then the final unrounded bearing is the unadjusted bearing plus the correction, which gives you 82, 16, 58, and so on for each one, adding across this way like so. And that yeah, brings you there. And then to get to the final bearing rounded, you just round them to the nearest 10 seconds. So 58 becomes 16, 58 becomes 17, 22, 36 becomes 22, 40, 46, 15 becomes 26, 10, or 46, 20. You can either one would be correct. 270, 0, 23 becomes 270, 0, 20, and so on and so forth. So yeah, I'll just put the screen back. So I'm hoping that that's answered your question, unless you've got further questions that you want to ask about that particular one. So yeah, how's that working for you? I have to talk for 30 seconds so I can give you a chance to respond. But yeah, okay, cool. Oh, that's good. If you've got any more questions, it'd be awesome. More than happy to watch them, or to try and answer them anyway. Answer any questions. They don't have to specifically be about the Land Surveying 1 course. If you've got any questions about land surveying and any land surveying questions, I'm quite happy to attempt to answer them. So yeah, go for it. So while we're organising questions, I'll just talk about some of my simple survey concepts that I bang on about every now and again. So I'll just transition over to there. Simple survey concepts. The first simple survey, or this simple survey concept, is about an origin, and how standard practice is to, in any survey, is that we must find 3 old marks that, and then prove the relationship between them is true, or it agrees with the information that we have on the plans and what have that we've provided. So yeah, quite common when you're out in the field and you turn up and at the house of the client, just to let them know that you're there, going to do their survey, you know, determine where their boundary is or position their shed, and then you sort of go about 400 or 500 meters down the road and start looking for marks and things. On more than one occasion, the client has come up to me and said, "Are you still working on my job?" Yes. So we have to go sometimes quite a way if there's been sort of a lot of construction work in an area. Sometimes we've got to go quite some distance to find an origin, as some of the survey marks might have been obliterated by construction or footpath reconstruction or road resealing or that type of thing. So and sometimes not possible to find suitable consecutive marks and things like that. So we've got to find 3 marks, and we typically nominate the bearing between 2 marks to be the origin of bearings. And so in this case here, well, let's say mark 1 and mark 2. So we set the bearing off our plans from mark 1 to mark 2, and we measure the distance. So the distance, you know, is agreeable within a certain thing, but it doesn't really prove that the marks are in the correct relationship, because you know, they could have moved in such a way that the distance stayed the same, but the bearing was not correct. So that's why we need a 3rd mark, in this case here mark 3. So if we set the bearing mark 1 to mark 2, whatever it might be, and then measure the bearing, or the angle, essentially the angle, mark 2, mark 1, mark 3, we measure that and get some agreement on that, then we say we've proved our origin, and that's when we can start work adding new marks or putting in pegs or things like that, because we know exactly where we are. So that's a very important part of what we do. You know, we must know that we're in terms of the local marks and the local survey data. So yes, and then we can proceed on. There are various ways of doing this. Sometimes it's not possible to get 3 consecutive marks like that, so we might have 2 marks and then a bit further distance away another 2 marks. But I mean, there are various ways, but this is the classic way that we prove our origin, like this. Ideally, it's good that if we have an angle too, rather than having 3 marks on the one line. So quite often we'll line marks in on a line so that we can do that, but it's best to that. It's also you know, you want to use long lines as your bearing origin, because you know, the better the marks are, you know, the distance, the less error there is. So if you have a very short origin, you only have to be a few millimeters adrift, and that can be a significant amount of bearing, that when you go further away, that error will get multiplied and exaggerated. So I've only got one watching left here, but I'll go till 8:30. I've been going 19 minutes and asked a few little questions there. So I'll just move on to my next slide here. which is the types of traverse. So when we traverse in surveying, now traversing is our most, well, in terms of with a total station, is one of our most accurate ways of establishing what we call survey control. So we traverse between marks where we know of known coordinate or known value, or we traverse round in a loop, and so we're able to calculate that when we are at the start of the loop and we go through our traverse, there's no holes in our traverse, we end up where we started. If we measure from A, when we measure from A, B, C, D, and perhaps back to A, we do in fact come back to A, and we do this by calculation. So this is quite a good way of trying out our establishing control. But that's not always the case. That's a closed traverse, a loop or closed traverse, when we have a closed network like a polygon with 6 sides or something like that. But there are other instances where we can close between two marks with known values, and this tends to be like a link traverse. So we might have two separate traverses, and then we join between the two using values from each of them, and we can close on coordinates. So this is called a closed link traverse. And these are possible, under most circumstances, are sort of accurate as the closed or loop traverse. But you do become dependent on another person's work sometimes, or different instances of your own work. So there can be some problems with this sort of thing. So especially with the use of GPS and that these days, it isn't quite easy to actually close your own work, and then you can be absolutely sure that your work is error-free. And this is something that I've been liked to do myself, is to, where possible, close my own work so I can be sure of the accuracy of my work, and then I can then sort of look at there being inaccuracy in other people's work and how we might deal with that. Then there's another type, a third type, which is the hanging or open traverse, which has no checks and balances on it at all. You just measure out, measure out, measure out. So if you make a small error, it's going to be included in the traverse or open traverse. And so it just starts with a set of data. There's no close, so we can't do any calculations to to check that it's in agreement with other marks in the area and things like that. So these are to be avoided if possible. And as I said earlier, particularly now with the use of GPS and such things, there's not too much going on in that sort of this sort of thing can be very easily avoided, and is unnecessary really these days, unless only in very certain circumstances. So I'm just down to one watcher now. I'm not sure who that is, but as I said, I contracted to keep going till 8:30, so got another 6 minutes to go. And then if we don't, there's nothing there for me to do, no comments to make or questions, then I'll wind it up there. So let's move on to my next slide. And this is about bearings, a concept that some people have had some difficulty in grasping, it would appear to me, that bearings are measured clockwise from north. I've been doing this thing so long, I think, that to me it's a concept that's quite ingrained, and I sort of work with a compass in my head, although I do often sort of get lost really, and sometimes in things, and but I do know where my bearings are. Yeah, so I quite often can get a little bit disorientated in buildings and things, and people are often pulling me up for when I say, oh, go to town over there, and they'll say, oh, don't you mean over there? But I tend to talk in general terms and wave my arms in all sorts of directions, really. I don't think it's particularly related to my sense of direction. So bearings are measured clockwise from north. Now this is quite contrary to a lot of other concepts. So we start here at north, which is, as I'd say, where the sun sits at midday. So if you're outdoors, you can sort of think, well, around about midday or 1 o'clock if it's daylight saving, where the sun is, that's going to be approximately north, and then you can work around from there. And they go clockwise. The bearings go clockwise from north. So they'll go from north through 45 to northeast, another 45 to east. So that's 45, 90, 135 to southeast, and 180 to south. And then continue on southwest at 225, west at 240, northwest at 315, and then they come back around to 360 at north. Okay, so that's it really. And it's a wee bit different from maths, because maths, their 0 is here at east at around 90, so that's the 0 there. And then they go anti-clockwise, 0, 90, 180, 270, 360. So the mathematicians are totally different to bearings. Now when I say bearings, I mean here in New Zealand, because in other countries they talk about the bearings in terms of the quadrants and where they fit in the quadrants and that sort of thing, and that's a whole different thing again. But here in New Zealand and in my courses in particular, we go clockwise from north, so north and we round and so on and back. And you can't have a bearing of greater than 360. They only go from north to 360. When you go past 360, you start at 0 again. And typically we measure our degrees or our bearings in degrees, minutes and seconds. There are 60 minutes in a degree and 60 seconds in a minute. So yes, it's quite a busy little circle around here. If you take 360 and you multiply it by 60 and then you multiply that by 60 again, it gives you a very large number. And it's quite incredible to think that in a little total station or that they can actually that the circle, which is usually quite small, is divided, or can divide that into that many parts. It's actually 1,296,000 seconds around the circumference of a circle. So if you're looking there, that's just got 360 degrees, and then each one of those, each little division there is divided into 3,600 bits. So yes, it's quite a bit going on there. So it's coming up to 8:30. There doesn't seem to be any more questions or comments. I'll just come back here to my, you can see me there. I think I'll just wind things up at 8:30. It's about 30 seconds to go, so unless I hear otherwise, I'll just finish up unless there's any more questions. The one person watching out there, if you've got any more questions, better get them in quick, because I'm going to turn it off, and probably it's coming up to 8:30, so before it turns 8:31, Should give you enough time to get any questions or comments in there. It's gone 8:30 now. We've got about a 20 or 30 second delay, so please, if I do cut you off, yeah, I'll tell you, I'll probably just stop talking at 8:31 and just let it drift out. I'm still working on the best way to finish these things off, actually. So I'll let it. I'll stop talking at 8:31. Cheers. Thank you. And then I'll leave it go for a couple of minutes just to see if there's anything happening. I think that's a bit of wishful thinking on my part, but anyway, with my one viewer there, we'll see how we go. Alrighty. So yeah. Oh, thanks, Giselle, if you're still there. Hopefully, I got a couple of questions answered there, and that might be of some help to you. The test is actually coming up on Wednesday, and I'm just going to, once I stop this, I'm actually going to start writing the new test. So that's it from me. Cheers. See you, unless I get another question.